In this video, I am going to discuss previous year questions from the number system concept. So I have collected all these questions from the previous year GATE exam. GATE exam questions, all these questions from the GATE exam, and the topic name is a number system. So previous year GATE exam questions from the number system concept. Yeah, first of all, go through this question. Convert octal number into the hexadecimal number. This number system is a octal number system, and we have to convert into hexadecimal number system. That means base 16. Then how to convert octal to hexadecimal? Now it is comes under other number system to other number system. We have two procedures. First of all, convert this other number system into a decimal number system, and later we convert this decimal number system into hexadecimal number system. This one is standard procedure. And one more technique also there is an easy technique, simple technique. Convert this other number, octal number system into binary, and binary number system into hexadecimal number system. This one is the first technique, and it's a second technique. So second technique is the easiest one for this type of conversions. First of all, I'm writing this 257 in terms of binary format. How to write binary format? Write each digit in 3-bit binary. Each digit in 3-bit binary. 2 equivalent binary is 0, 1, 0. 5 equivalent binary is 1, 0, 1. And 7 equivalent binary is 1, 1, 1. So this comes under a binary number system. Later convert this binary number system into hexadecimal number system. So to convert binary to hexadecimal, how many bits are required? 4 bits are required. From right side onwards, divide 4 bits here. From right side onwards. Here 4 bits are separated, 4 bits are separated. 0 value is 0, 1, 0, 1, 0 equivalent value is 10, 10 equivalent hexadecimal number is A, and 1, 1, 1, 1 equivalent value is equivalent decimal number is 15, 15 equivalent hexadecimal is F. Finally, the result number is AF. It is a hexadecimal number system. So answer is AF. 5, 6, 7 into hexadecimal number system. Again, I'm writing this 5 in terms of binary format. So 1, 0, 1, 7 in binary is a 1, 1, sorry, 6 in binary is 1, 1, 0, 7 is a 1, 1, 1. So 1, 0, 1, 1, 1, 0, 1, 1, 1. It is a binary number system. Later convert into hexadecimal. Divide the complete number in 4-bit format like this. Then what is equivalent value? 1, 0, 1, 1 is 7, 0, 1, 1 is 7. Then equivalent hexadecimal number is 1, 7, 7. Simple conversion technique. Yeah, another different method question here. Identify the number of ones in a given number. So one number system is given here. In this number system, just we have to find out the number of ones. How many number of ones are defined in this? See, to determine the number of ones, always we require binary number system. Because binary number system consists zeros and ones. From that we can find the number of ones only. So that purpose, always we have to convert the given number system into binary number system. First of all, we have to know this is comes under which type of number system. Just try to observe the complete number, given number. Here 8 into 1, here plus is there, 7 into 16 plus is there, and 9 into 256. Just identify these numbers, 256, and this one is a 16, and this one is a 1. So just to go through these numbers, just try to identify these are comes under which positions, position values. So suppose base is 8. Position values are 8 power 0, 8 power 1, 8 power 2, 64 like that. If the base is 16, then the position values are 16 power 0, 1, 16 power 1, 16, 16 power 2, 256. Now see, these position values are given. It looks like 16 power 0, this is 16 power 1, and it is 16 power 2. That means the given number system is a hexadecimal number system. This is comes under other number system to decimal number system conversion procedure. So I'm writing that number now. 9 into 16 square plus 7 into 16 power 1 plus 8 into 16 power 0. So just I'm writing these digits separately. This 9 digit, 7 digit, and 8 digits. So we can write a 978. It is a hexadecimal number system. To write equivalent binary, first of all we require the type of the number system. So it is comes under hexadecimal number system. Based on the position values, we have to identify that. And later write this number in terms of binary format. So 9 equivalent binary is a 1001 7 equivalent binary is 0, 1, 1. Use 4 bits because it is a hexadecimal number. Hexadecimal to binary compulsory we have to use 4 bits. And 8 equivalent binary number is 1, 0, 0, 0. So write the complete one now. 1, 0, 0, 1 and 0, 1, 1, 1 and 1, 0, 0, 0. It is a binary number system. Then we want a number of ones. Number of ones in a given number system. How many ones are there? 1, 2, 3, 4, 5, 6. 6 ones. 6 ones. So finally the answer is 6. These type of questions also important because up to now we have studied the number system concept, different types of number system conversion part, and sometimes we can expect these type of questions also. That purpose we require the complete knowledge from the number system concept, then only we can answer these type of questions. Only one more question from this concept. Identify the number system. Which type of number system? Just we have to identify the number system only. So just go through the weighting positions. Here 8 is there, 64 is there, here 1 is there. So 8 power 0, it is comes under 8 power 1, it is comes under 8 power 2. That means the given number is 745 base 8 octal number system. So suppose I want to convert this number into binary, write each digit in 3-bit binary. So 7 equivalent number is 111, 4 equivalent number is 100, 5 equivalent number is 101. So now it becomes a binary number system. So identify the number system. So that purpose just to find out the position values. Another previous gate question from the number system concept. The number -6 can be represented as a 1010 in 4-bit 2's complement representation. Which of the following is a correct 2's complement representation of -6 using 8 bits? So one number -6 in terms of 2's complement representation is given. That number is a 1010. Then we want the same number -6 in using how many bits? 8 bits. So the given problem statement consists the -6 in terms of binary format using how many bits here? 4 bits. So equivalent 4-bit representation is given. Then we want here equivalent 8-bit representation. Then follow the standard procedure. From the 2's complement representation, if you want to extend the number of bits, write MSB bit as it is. So extension of the number of bits. See, I am writing here 10104 bits. Then we require how many bits totally? 8 bits are required because write the complete form in 8-bit format. So to write 8-bit format, just you have to extend the MSB bit. Most significant bit is this one. This is comes under most significant bit, MSB bit. Extend that number as it is. So 1, 1, 1, 1. I am writing 4 times. Total number of bits how many times here? Total number of bits 8 bits. So it is a 8-bit equivalent 2's complement representation of which number? -6. Just follow the simple procedure, simple technique. Extend the MSB bit. If the MSB bit is 0, just you have to write a number of zeros. If the MSB bit is 1, then write a number of ones based on the number of bits. If suppose I want 16 bits, write again once 1, 1, 1, 1, 16 times. Totally we want 16 bits means write 12 times because already 4 bit is there. 12 1 right, so 12 ones then gives the equivalent 16-bit 2's complement representation. This is also one of the simple question. Another previous year gate question. Which of the following is equal to 224 in radix 5 notation? So here one number is given. This is a 224 radix 5 number is there. Then in given options, few numbers are there. One is 64 with radix 10. This is 64 with radix 10, and one more number 100 radix 8. Then another number 50 with radix 16, and one more number 121 with radix 7. So just we have to identify this base 5 number system equivalent to which number here? Base 10, base 8, base 16, and base 7. That purpose, just I want to find out the equivalent decimal numbers. Convert other number system into decimal number system. So here I am writing other number system into decimal number system. So to convert others to decimal, just multiply by the base powers 5 power 0, 5 power 1, and 5 power 2. 5 square. 5 square value is 25. 25 into 2 is 50 plus 5 to is 10 plus 4. Then it becomes a 64 base 10. So the equivalent decimal number is a 64. So 64 is there. So we can select this one. Similarly, we have to check other options also. I'm taking 100. 1008. Convert into decimal number system. So decimal number system is, it is multiplied by 8 powers. 8 power 0, 8 power 1, 8 power 2. 8 power 2 into 1, 8 power 1 into 0 plus 8 power 0 into 0. That becomes a 64. So this option also correct. Similarly, one more. 50 with base 16. Again apply the same procedure. 16 into 5. 16 5 is 80. 80 decimal number. So it is not equal to 64. So that's why this one wrong. And one more also there, that is a 1 to 1 with base 7. 7 power 0, 7 power 1, 7 power 2. 7 square into 1 plus 7 into 2 plus 7 power 0 into 1. So 7 square 49 plus 7 to the 14 plus 1. Just add all these numbers. This gives the 64. So this is also equivalent to the 64 in decimal. That's why we can select AD. So this type of questions comes under multiple selection questions. So from the given options, more than the one option will be correct here. So multiple selection questions, which options are correct? A, B and D. These three options are correct. That purpose, you have to check compulsory each option. Another previous year GATE question from the number system concept. Considering a system that uses 5 bits representation signed integers in 2's complement format. In this system, two integers, A is 01010 and B is 1101. Which one of the following operations will result in either in arithmetic overflow or in arithmetic underflow? So first of all, we have to understand clearly this problem statement. This binary data representation is given in 5 bit. So n value is how much here? 5. Number of bits are 5 bits. In which format? 2's complement format. First of all, we have to identify the range of the 2's complement representation. Range of the 2's complement representation using n bits is minus of 2 to the power of n minus 1 minus 1 2 minus of 2 power n minus 1 2 plus 2 power n minus 1 minus 1. So this one is the standard formula which explains the range of the number system. So this number explains the minimum number using n bits and this number explains the maximum number using n bits. Now based on the given problem statements, how many bits are there? 5 bits are there. That purpose I am writing a range of the number system in 2's complement minus 2 to the power of 5 minus 1 2 plus 2 to the power of 5 minus 1 minus 1. Then what is the number? 2 to the power of 4 is a 16. So minus 16 2 plus 15. So we have to take only these numbers only. Minus 16 to plus 15. After performing some operations, some arithmetic operations are there. Which one are the following operations? Some arithmetic operations are given. Addition, subtractions are given. So in which case it gives the overflow and underflow. That means after performing the arithmetic operations, the result consists less than this number, less than the minus 16, then it is underflow, more than the 15, then it is a overflow. So we have to identify that combination. So first of all, I am performing here one operation, A plus B operation, addition of these two numbers. So first of all, I will write the equivalent values. A value is let us write 0 1 0 1 0. See, the first number is 0, then the number is positive. MSB bit is 0, then the number is positive. 1 0 1 0 equivalent value is 10. So this number equivalent value is 10. And similarly, I am taking B number. B. The value is number is 11010. Go through the MSB bit. MSB bit is 1, then the number is negative. MSB bit is 1, then the number is negative. Then the equivalent magnitude explains the 2's complement of this number. 2's complement of this number is 0, 1, 1, 0, 0. That is 6. So B value is how much here? Minus 6. So I'm writing here A is equal to plus 10 and B is equal to minus 6. So first of all, I'm performing this operation A plus B, 10 minus 6. 10 plus minus 6, that is equal to 4. See, this 4 is defined within this range. So it does not give the overflow condition, underflow condition. Second combination I'm taking now. A minus B I want to perform. A number is 10 minus of minus 6. So then it gives the minus into minus plus. 10 plus 6 is 16. Now the number is plus 16. Plus 16 is greater than the plus 15. So which gives the overflow condition here, which gives the overflow. Right? One more combination also I'm taking now. Yes, just I want to perform the third operation, minus A minus B. Minus A minus B. So minus A value is 10 minus B value is minus 6. Then minus 10 minus into minus plus 6, then it becomes a minus 4. It does not give the overflow condition. So minus 4 is comes under within this range only, minus 16 to plus 15. Now one more combination I am taking now, minus A plus B. Minus 10 plus minus 6. Now it gives the minus 16. See, minus 16 is also comes under this range. This one is the minimum number, so which does not give the underflow condition. So this is also does not give the underflow condition. Only one operation it gives the overflow, that is A minus B. Based on the given numbers, 2's complement representation, A minus B gives the overflow condition. So like that we have to identify in which case it gives the overflow and underflow. And in that gate question some options are given. So here just I'm explaining with the different types of operations how to determine the overflow and underflow conditions. Another previous gate question, the smallest integer that can be represented by an 8-bit in 2's complement form is. In 2's complement form, using n bits, range of the number system is defined as minus 2 to the power of n minus 1 2 plus 2 to the power of n minus 1 minus 1. So this number explains the minimum number and this number explains the maximum number. We require which number now? Smallest possible number, that means a minimum number. So smallest possible number should be minus 2 to the power of n minus 1. So n is equal to how much here? 8 is there. Substitute that one. Minus 2 to the power of 8 minus 1. So that is minus 2 to the power of 7. Then the minimum possible number is minus 128 using 8 bits. Maximum possible number is plus 127. The range of the number system is minus 128 to plus 127. So to write or to determine the answer of these type of, or to determine the solution of these type of questions, we require this formula. So this is generally comes under the binary data representation. Binary data representation, unsigned representation, signed representation, 1's complement representation, 2's complement representation. Totally we have to use 4 data types representations. So those are required. From that we can find the answer. Like another previous gate questions from the number system concept. Let the representation of the number in base 3B210. What is the hexadecimal representation of the number? So the given number is a base 3 number 210, base 3. Then we want here hexadecimal number system. Now this is comes under other number system to other number system conversion. Already we have discussed a simple technique to convert other number system to other number system. First of all, apply others to decimal conversion and later decimal to other conversion. That means first of all convert this number 210 with base 3 into decimal number system. How to write the equivalent decimal number system? Multiply by the base power. So 3 square into 2 plus 3 power 1 into 1 plus 3 power 0 into 0. Position values. This one is 3 power 0, 3 power 1, 3 power 2. Then the value becomes now 3 square is 9, 9 to 18 plus 3 plus 0. 18 plus 3 is 21. It is a equivalent decimal number system. 18 plus 3 is 21. Then write equivalent hexadecimal number system. 21 is a decimal number system and convert into hexadecimal number system. So to convert a decimal to hexadecimal number system, divide the given number by the base 16. 16, 1 is 16. So base is here. 21 minus 16 is 5. Write the remainder here. And again 16 zeros 0 and remainder is 1. Then the equivalent number is 1, 5. Just we have to apply the procedure others to other number system conversion, others to decimal number system and decimal to other number system. So already I have explained these techniques in number system concept. So please go through those videos and later try to practice these type of problems.